So quickly you just try to solve. Tell me the solution. Two machine parts, part and part. Machine part 1 and machine part 2. You represent the machine type for these parts. The machine type available have different methods and the profit of it. Tell me, can you able to do this? Machine parts, part 1 and part 2. So, what is the value required to produce this machine parts 1 and 2? In late, it's equal to 12 minutes, maybe 4 and similarly for the 2. And what is the maximum time allotted? The maximum time is available for the day. It is 8,000 minutes for the minutes and 9,000 minutes. And once the products are sold, question you have written? Keep ready your calculator in front of you. If you are using the scientific calculator, it will be better. Okay. So for the smallest positive root, what I told you, you have to search from origin to right hand side in 2 points. In between that 2 points, suppose your graph will cross the x-axis. So root is lying in that interval. In Newton-Raphson method, nearby any value from that point, you have to take as a initial condition. Okay. Okay. Suppose for any equation you do have more than one solution, and then in which neighborhood? Suppose one question I am writing here. A equation it will do have looks like this type of structure. Okay, so this equation where it will cut the x-axis, this is also a solution, this is also a solution, this is also a solution. So if you will take the initial condition x0, suppose here it is nearby this point, so it will converge, try to give you the solution this one. If you will take initial condition, suppose here, then you will with the help of that method it will try to converge the solution in this point. If you will take here initial condition, it will try to converge this point. Okay, so try to for that process in the question it will be at least information will be given to you. Find out smallest positive root, largest negative root, or sometimes real root. So you just try to searching from origin to right hand side any 2 points, and then when you will get 2 points where the function will change the sign, between any points you just try to keep initial value. Okay, so tell me what is, suppose this is fx, you just keep ready your calculator. By default you are putting any value in this function and you are calculating. This is with the help of calculator. Keep your calculator in radian mode. Okay, because by default whatever the, suppose you are considering x value 0, 1, 2, these are the radian, and if your calculator is in degree mode, then along with the degree, so whatever the x value you are considering, along with that you have to multiply 57.273 like that. Okay, because 1 radian is equals to 57.273 degree. So you just try to keep your computer in radian mode such that you don't have to multiply that much amount. Tell me what is the, and what is f dot x?
Sir, minus sin x minus 5.
Minus sin x minus 5. In these techniques, these things we need. Okay, so before that you just pick up any 2 points or which value you will take initial solution. That idea you got? Yes. That scientific idea is which value you have to take initial condition, and when you have to stop the iteration process, that idea you have to take the idea from this point, okay, up to 3 decimal places. Means in 2 consecutive iteration, it is matching the result up to 3 decimal place. You will stop your iteration, and which initial condition you will pick up. For that purpose, you just at least try to find out 2 values where the graph is changing sign. So tell me, what is F0? Positive or negative, at least? F0 is
Positive, sir.
this is positive. What is F1? Positive or negative, at least? Cos 1 minus 5 plus 5. So cos 1 means that 1 is the radian. So keep your calculator in radian mode. And if it is in degree mode, then you have to multiply along with the 1 57.273, because 1 radian equals to 57.273 degree. And that is why I am telling you that much information you just keep in your mind. When you will calculate for this type of calculation in calculator, keep your calculator in radian mode. What is cos 1 radian means? Positive or negative? Cos 1 minus 5 into 1 plus 5. So 5 cancel. So cos 1 radian, what is that value? Do you have calculator? बोलो कोई कैलकुलेट करो.
It is coming positive, so 0.541.
0.541.
541.
So it is still positive. Means in 0 it is graph is lying above of the x-axis. In 1 also above of the x-axis. Again you just try to calculate 2. What is 2? F of 2 is positive or negative? You just tell me.
Negative, sir.
This is negative.
Negative.
It is
Negative, sir.
okay, no problem. So your graph is actually whatever in 1 and 0 and 1 it is above the x-axis like that. And suppose this is the 2 points. This is 1, this is 2. In between 1 to 2 it is negative, means below of the x-axis. So in between 1 to 2 it is crossing the x-axis. So obviously this is the solution. And I told you in between 1 to 2 any value you may consider as the initial solution. So let's consider suppose x0 is 1. 1 to 2 means x0 is 1. Then you just put in the iteration scheme. What is the formula? Xn plus 1 equals to xn minus f of xn by f dot xn. This is the iteration scheme. In that iteration process, you just put n equals to 0, suppose here. Okay. N equals to 0 means x0 minus f of x0 by f dot x0. This value you can able to calculate. This value you may able to calculate with the help of this function and f dot. Isn't it? So you will get left hand side step by step every iterated value, suppose x1, x2, x3, like that. When in 2 consecutive iteration up to 2 decimal place it will match, you have to stop your iteration. Okay. So for that purpose, suppose you are giving n equals to suppose 0 and less than, I am putting here lots of iterations, so no problem. After 1 or 2 iteration later, or 3 iteration or 10 iteration later, suppose you will get, I am giving here maximum iteration like that, and I am putting that condition So if FABS absolute value of two consecutive iteration xn plus 1 minus xn less than 10 to the power minus 3, or suppose that is the root, or suppose that is the root, then f of ABS f of x n plus 1, whatever it is, f of xn plus 1 less than 10 to the power minus 3. Then you have to stop the iteration. Obviously, loop will be break, and at the out you just try to print the solution. You got this idea? Manually for the theory
Yes,
exam,
sir.
for the theory exam, you just try to calculate manually like x1. x1 equals to x0 minus f of x0 by f dot x0. What is x0? x0 you have considered 1 minus f of x0. f of x0, this is the fx. So f0 already you have calculated here. Means cos of x0 means 1 minus 5 into 1, 5 into 1 minus plus 5, that is the fx. By f dot x is minus sin x minus 5. So you just put that value here, minus sin 1 minus 5. Can you able to calculate this?
Yes, sir.
Tell me values.
Sir, it is 1.0924.
1.0924. It's okay, no problem. That is your x1. 3 decimal place, at least you just try to keep or write at least 3 or 4.
Yes.
Up to 4 decimal place you just write. That is the x1. Okay. Now to get x2 with the help of x1, you have to put, that is f of x1. f of x1 means cos 1.0924 minus 5 into 1.0924 plus 5 by minus sin 1.0924 minus 5. What is this value? You just tell me. That is the x2. x1 is you have to take from here. Okay.
Sir, it is 1.09212.
1.092112. Okay, no problem. I can stop here. Okay, I can stop here. Tell me why.
2 decimal places are matched.
On the basis of question, it is asking you up to 3 decimal place. You just see here. It is up to 3 decimal is matched. 1.092. 1.092. So I can able to write approximate or better approximate in this method. The solution is 1.092. 1.092. You got this idea? If you are thinking this is the root or solution, you just put back this value in the function, main function, f of 1.092. I am sure it will give you 0.2 times at least 0. Whatever, it can be positive or negative, that does not matter. That is why I have taken f of ABS functional value at that point, solution. It is looks like 0. Its modulus value will be approximately 0. So you may say this is the solution. Not exact, but better approximate in this method. Tell me about this value, f of 1.092.
Yes, sir.
How it is coming? 0.00 something is coming or not?
One second, sir.
F of 1.092, because you are thinking this is solution. If it is exact solution, then it, for any equation, this is equals to 0. Any exact solution you will get, you put that solution here, it
Sir,
will
it is coming as 0.000711.
0.00711. No problem. So you have written that structure here. Within the loop, you have to give in 2 consecutive iteration, it is matching up to 3 decimal place. That is comment this. And if you will check in any iteration, that iterated value is thinking, you are thinking this is the solution. So that functional value is less than 10 to the power minus 3, means it is looks like 0. Okay. So you may say this is the solution. Have you got this idea about Newton-Raphson method? Any problem?
No, sir.
I think any equation if I will provide you, I think you can able to solve now. Okay.
Yes, sir.
And after that also we are going to discuss some another method. That time also we'll practice some numerical example. Tell me, any query?
Yes, sir. Sir, in the last step, we are putting the value of 1.092 in the above equation. No? That
This is actually for verification purpose.
okay.
This is for the verification purpose. I told you. You just try to. This is the solution. Up to this much is the answer. This is logic. Is you know any equation fx equals to 0 is the equation. Mathematically, if you are getting the solution x equals to a, suppose, then f of a will be 0, isn't it?
Yes, sir.
So you are thinking it is not exact solution. This is approximate solution. But still it will, if you will try to verify in the main equation, it will give you looks like 0. And for the verification purpose, I told you, you just try to verify this.
Got it. Sir.
Okay. So in this technique, having also some plus point, minus point, or when you can able to use that condition, or what is the speed, that is known as the rate of convergence, in which speed it is approaching towards the solution. For that purpose, in the yesterday I told you little bit definitions. The condition of convergence you may check if the function you are trying to iteration scheme you are trying to write in x equals to phi x format, then mod of phi dot x should be less than 1. That is the condition of convergence, isn't it? Okay. And step by step in iterations, you have to calculate the error along with the previous step iteration, how the error is related. On that basis, from this relationship, you can decide the speed by watching the p value. Okay. So for the Newton-Raphson method, you just try to check and tell me what is the condition and what is the rate. So suppose, first of all, I am trying to logic is any iteration scheme is x equals to suppose phi x, then mod of phi dot x should be less than 1. Condition of convergence for Newton-Raphson method. So you just tell me this is the iteration scheme. Suppose x of n plus 1 equals to x of n minus f of xn by f dot xn. If I will suppose n plus 1 and suppose n is very large, n, then you may able to write this equation x equals to x minus f of x by f dot x, isn't it? And that right hand side is looks like you just say phi x. Isn't it? So your phi x is x minus f of x by f dot x. So what is phi dot x then? What is phi dot x? Here, if this is your phi x, then what is the phi dot x?
1 minus f dash
1 minus
f dash x by
f dot x square.
F double x.
double
It's square first of all.
Yes, sir. F double dash x into fx.
F double dot x into
fx minus
minus
fx square. F dash x square.
again. Okay, no.
Square, sir, square.
So if you will do this 1 minus plus, actually this is okay. So if you will break this in partial fraction, so this by this minus this by this means 1, that minus plus 1. Okay.
Yes, sir.
I think we have done wrong calculation here. 1 will be cancelled here. That value will be first and that value will be second. So just try to.
Yes, sir. Yes, sir. Just change the sign.
Okay. So that value in this position. Okay. That is plus and that will be minus. Okay. So 1
Yes,
minus 1 will be cancelled and that minus plus. So this value is f double dot x fx by dot square. Its modulus value I told you. So its modulus value should be less than 1. Okay. So square is positive. Simply I am keeping the modulus value here. Okay. So from here I am trying to draw f double dot x into fx should be less than f dot x square. This is the condition of convergence for the Newton-Raphson method. Okay. This is the condition. And if I will try to implement this is geometrically, actually, if your graph is graph near the root, suppose your graph here is the root and graph near the root is vertical, suppose near the root is vertical, then it will immediately converge to the root. Quickly you will get the solution. Suppose your root, I am telling you, your graph is looks like this. Okay. Tell me, whatever the initial condition you will put here, suppose I am considering here initial value here, that is the x. And if I will try to draw a tangent here, that tangent will be looks like solution. Tangent is also cutting where the graph is cutting the x-axis. So near the solution or near the original solution, if the graph is looks like vertical, then vertical means its tangent 10 value is looks like 1090 degrees infinity. So it is looks like looks like infinity. Okay, so something by infinity is 0. That time automatically your iteration scheme will converge quickly. Xn equals to Xn. If this portion is 0, suppose, then Xn plus 1 equals to Xn. So whatever the next iterated value is, that is equals to the previous iteration value. Logic is clear. So that is also decided from here also. So physical interpretation. Graph near the root is vertical. That time your method is converging quickly. Okay. If graph is near the roots like that, here is the root, suppose. Here is the root. Graph is near the root, it is horizontal, looks like. For the timing, you just try to think. Wherever you are trying to do initial condition, suppose x0, here you are trying to draw vertical line and you are trying to draw a tangent. Tangent is also, suppose, tangent is also parallel to the x-axis, suppose. I am thinking it is not cutting the x-axis. Then this method is not applicable. Okay. So near the root is your graph is looks like horizontal, then method is laborious or it will take lots of iteration. And if the near the root your graph is vertical, then it will quickly converge. And that these are the conditions. And mathematical relationship is this. You got my point? Students, response me.
Yes, sir.
You got the point? So just try to keep in your mind its physical interpretation actually. If the graph is near the root is vertical, then you will get quickly result, means quickly it will converge. If near the root it is looks like horizontal, then it will converge so slowly, or process will be the laborious. And if it is exactly horizontal, then this method is not applicable near the root. Okay. Now let me
Yes, sir.
see or check about the rate or speed. In which speed it is approaching towards the solution. Suppose it is converging. Suppose you will get the root. Then what is the speed of that? So for that purpose, little bit mathematics calculation I am trying to do. Suppose your f of x equals to 0 equation, and I am thinking A is the exact solution. A is the exact solution. X equals to A is the exact solution, and f of A, obviously f of A will be 0, isn't it? But mathematically it is not able to solvable, or for that purpose you are trying to adopt some iteration method and trying to step by step doing the iteration, you are trying to approach towards the solution A. Okay, so in any iteration, suppose nth iteration, you will get the, in nth iteration you will get the nth iterated value, and that is xn. Tell me, this is exactly A. Is this exactly O? This is approximate to A. Okay. So what is there in that iteration? Suppose you do have some error. That error I am writing here. That error I am writing here, epsilon. Suppose epsilon. In nth iteration, it is I rename as n. Then I may put this is exactly equals, isn't it? In nth iteration, whatever the value you are getting, that is the iterated value, approximate value. So along with the approximate exact some deviation is there, obviously that error term is epsilon n. So a equals to that exact value will be the iterated value and some error, isn't it? Is it okay?
Yes, sir.
Then you just tell me f of xn plus epsilon n equals to 0 because it is now become the exact. Okay, epsilon error is small, so you are try to write this expression in terms of Taylor series expansion. Okay, so this will be f of xn plus epsilon n f dot xn, sorry, f dot xn plus epsilon n square by factorial 2 f double dot xn up to infinity, Taylor series infinite series expression. Okay, so since error is very small, so I am neglecting the after that term, after that higher power of the error, that terms I am neglecting and I am trying to write this expression a little simply. Okay, that expression I am trying to write, suppose f of xn plus epsilon n f dot xn plus epsilon n square by factorial 2 means 2 f double dot xn. That will be, I am thinking that is the approximate 0 because higher terms I am neglecting. Actually, my target is to find the relationship like that. Okay, what is the error related along with the previous iterated error? Okay, the last day I told you this idea about the I have to establish this type of relationship. Okay, such that I will get some value of p, I can decide what will be the rate or speed of that method. Okay, and suppose in this method you will get p value 2, and that is why I am writing here. Let me check. Calculation is okay? Are you understanding?
Yes, sir.
Okay. Then what I will do, you just try to divide by this term both sides. This term, okay. So f of xn by f dot xn and plus epsilon n square by 2 f double dot xn by f dot xn. That is still approximately 0, isn't it? Mhm. You just bring this term right hand side and add xn. So what I am doing here, minus xn by dot xn equals to, if I will bring that is right hand side, that will be approximately epsilon n plus epsilon n square by 2 f dot x. In both side xn, suppose you just check here, I am adding both side xn. If I will add here xn and then xn, because this is the xn plus epsilon. You are adding both sides. So what will be this value then? This value will be xn plus 1. This is the iteration scheme. Iteration scheme at right hand side, nth iteration value, in left hand side you will get n plus 1th value. So this value is xn plus 1. And in nth iteration approximate value xn, and in that iteration error term is epsilon n. So by combining these two, you will get the exact value. Suppose exact value is a. This is the exact value because this is the approximate value in that term and this is the error term. So this is a. This is basically a. So a plus epsilon n square by factorial 2 f double dot xn by f dot xn. Up to this much clear? Now this is the exact value. You are thinking this is the exact value. Okay. Here is the exact solution. So in n plus 1th iteration term, iterated value is xn plus 1. So exact minus iterated, that is in that term the error term. So you exact minus n plus 1th iterated value will give you the error term in n plus 1th iteration. So that is I rename as epsilon n plus 1. And these error are absolute values actually. You may consider this is modulus, no problem. So that is approximately equals to epsilon and square by 2 double dot epsilon by f dot. Okay. So if I'll put back epsilon n plus 1 by epsilon n square, it's modulus value whatever, and because of this approximation, I am taking here mathematically limit n tending to infinity. I am doing lots of iteration. Okay, just a minute. হ্যালো, আমি ক্লাসে আছি, একটু পরে ফোন করছি। ঠিক আছে। So that is, if I will write, what will be the right hand side then? It will be half this. That is basically asymptotic error constant, right hand side constant term, and this is previous recent state, recent iterated error term, and previous iterated error term is epsilon n. Here you are getting the power 2. So you just see and check along with this previous step what is the definition I told you. Definition I told you. Can you able to see this? Okay.
Yes, sir.
So along with this, you just compare. This was the general definition. In Newton-Raphson method, p value you are getting 2. It is becoming almost 2. So rate of convergence in Newton-Raphson method is quadratic. Here that is 2 is coming. Okay. Is it okay? Therefore, by watching these two values, you will write here. Therefore, because of that two value, it is quadratic. And logically, that that value will be multiplied in every iteration decimal places. So in first iteration, suppose you are getting one decimal match. In next iteration, it will give you two decimal match. In next iteration, it will give you 2 into 2 means 4 decimal place. In next iteration, it will give you 8 iteration place. In that way, so quickly you will get the result. Okay. So theoretical importance is only up to this much. Okay. Rate of convergence, speed, condition of convergence, what is that method? Sometimes you have to derive, it will be asked to you, derive Newton-Raphson method geometrically. So that time, in which way, using the tangent idea, step by step, cutting the x-axis, that values are approaching towards the root, that formula you have to establish. Okay. In last class, I told you, na? That idea you have to, in which way we have established the formula. So that is also to you to solve. So I think you can able to solve. Bolo.
Yes, sir, we can solve that.
If numerical problem will be provided to you, in which way we have done two problems, in that way we will solve. And for the theoretical importance, whatever the terms I told you, you just try to keep in mind. Geometrically, formula establishment, rate of convergence, okay, or condition of convergence. You need this file.
Yes, sir, please upload the notes.
Okay, I will upload it. No problem. Okay, if you don't have any query, then we are ending the meeting. Any query?
No, sir.
Please upload the
Oh, sure, sure.
yeah.
I will upload
Yes,
it. Okay. In file section, you
Thank
will
you,
get
sir.
it.
yes, please.
So we are ending meeting. Okay.
Thank you.
You are
Thank you,
welcome.
sir.